Hello, my super kids. Welcome to another exciting lesson on quantitative reasoning. In this lesson, we'll be looking at two exercises 17 and 18. And in exercise 17, we're going to be looking at one example. Now, in the first example, we are going to be making use of these concepts. First, we are going to be making use of subtraction, multiplication, and finally, the use of imaginary numbers. Now, in this first example, we are going to make use of two imaginary numbers. First, the numbers on the left will help us to get the numbers on the right, making use of these two imaginary numbers. Alright, so now let's begin. What are these two imaginary numbers? Yes, the first one is times 3 and the second one is minus 5. Times 3 and minus 5. Alright, now let's look at the first number. And the first number is 2. So how can we get a 1 from 2? Let's make use of these two imaginary numbers. So we start by multiplying the 2 by 3. That is the first imaginary number. That gives us a 6. And again, we make use of the imaginary number 5 or minus 5. And that gives us 6 minus 5, which is equal to 1. So this is how we get the 1 on the right hand side. Alright, now let's look at the second number, which is 16, and how to get the 43 from it. So we start with the imaginary number times 3. So we have 16 times 3. When we do this, we will get a 48. 48. Alright? So it's time to use the second imaginary number, which is minus 5. So we take the result, which is 48, and subtract 5 from it. So 48 minus 5, that gives us 43. 43. So that is how we got the 43. Alright, now let's take the third one. The third number is 27. 27. And let's see how this is going to give us the number on the right hand side. First, we start with the first imaginary number. So 27 times 3. Now when we multiply this, we are going to get the number 81. 3 times 7 is 21. Put down 1, carry 2. 3 times 2 is 6 plus 2, 8. Alright? So we deal with the second imaginary number by subtracting 5 from 81. What are we going to get? Of course, 76. So that is why the number on the right hand side is 76. Now let's go with the last number, which is 40. 40. So let's see how we can get 115 from that. Alright. Now, as usual, we start with the first imaginary number, which is times 3. 40 times 3 will give us 120. That is, 4 times 3 is 12. Then you put the 0 behind it. That's 120. Again, we make use of the second imaginary number, that is minus 5. So 120 minus 5 is equal to 115. 115. All right. So this is how this exercise 17A is done. Now example 1 in exercise 18 uses the concept of division and indices. Now we will look at this much later. But first of all, let's look at the picture in example 1. Alright. The picture has an inverted V and is circled with a red ink. Then we also have the normal V. Now these are the two symbols that are used in this example. First, what does the normal V stands for? Well, the normal V stands for divide. So the sign of division, right? While the inverted V stands for index. It stands for index. Alright, so that is a number raising to another number. Alright, now let's deal with the inverted V. Alright, let's see what it really stands for. Since it represents index, so how do we best explain this index? We said index is the singular of indices. Then if we have a number like 2 raised to power 3 as we saw in the example, it means 2 will be written as a product in 3 different places. That is 2 times 2 times 2. Alright, so this is how it is. Now let's start with the first line where we have 4 inverted V2 and it's 16. Now how can you get 16 from that? 4 inverted V2, alright, means 4 raised to the power of 2. You see? And according to what we have learned so far, it means 4 multiplied by 4 in 2 places. And that is no doubt 16. So that is how we get the 16. Now let's look at the second line that has 36 normal V3. Now the result is there also, but let's see how this can work. 36 normal V3. But we said the V represents division. So that simply means 36 divided by 3. 36 divided by 3. Of course, the answer is clear. It's 12. 12 is the answer. So that is how we got the 12. Finally, let's look at the last line. An inverted V again. 3 inverted V3. Now let's see what we are going to get from this. 3 inverted V3. Alright, so that is going to give us 3 raised to the power of 3. 3 raised to the power of 3. Well, if we break that down, that gives us 3 times 3 times 3. That's 3 in 3 places. Well, if we multiply this, we are going to get 27. 3 times 3 is 9. 9 times 3 is 27. Alright, that is it for example 1. Now in example 2, we are making use of the concept of addition and subtraction. Alright, now let's get started. We have 4 numbers in this triangle that is lying down. This triangle is lying down, is horizontal, but we'll start with the largest number, the number 20. So when we make use of the numbers on the vertices of the triangle, we can get the number 20. So what do? We simply add up the numbers in the vertices. First, 5 plus 4 gives us a 9. 9 plus 11, and that gives us 20. So this is how we get the 20. It's quite easy, alright? Now let's go back and try to get other numbers. We are going to follow the same procedure, but let's start with the 11. Alright, now on the board, we are going to start with the 5 and the 4. So we have 5 plus 4. That will give us a 9. A 9. Now record there is a 20. So what do? We subtract the 9 from the 20. So 20 minus 9 is equal to 11. 20 minus 9 is equal to 11. So that is how we got the 11. So we can also apply the same method to get 5 and 4. Alright, so we can get the 5 and 4 using the same method. This time we are going to start with 20. 20, take away 11. 20 minus 11 is 9. Alright, so if we wish to get the 4 first, it means we are going to subtract 5 from the 9. So 9 minus 5 is 4. So that is how we get the 4. The same way we can get the 5 by subtracting the 4 from the 9. 9 minus 4 is equal to 5. 9 minus 4 is 5. Alright, that is all for this triangle. I hope you had a great time learning in today's class. I encourage you to do your quiz and your assignments. Thanks for watching, and bye for now.